Hopefully you remember from past lessons and courses the idea that an inverse is the undoing of a function. However, for trig functions, this is no different, but we must define how to undo something like sine and cosine. For example, if we have that the sine of x is equal to 1/2, how do we find what x is so that the sine is 1/2? Remember, for some theta, the sine is equal to the opposite over the hypotenuse. So we need some theta so that the opposite over the hypotenuse equals 1/2. Well, from our special triangles, we know that theta comes from a 1, 2 square root of 3 triangle, which tells us that theta is pi over 6. But what if we want to know, suppose the sine of phi equals 0.7? How do we undo sine? First off, what kind of functions have an inverse? Well, an inverse exists for a function if and only if that function is what we call one-to-one. If you remember from pre-calculus, we talked about the idea that a function, for example, has to pass the vertical line test in order to be a function. Well, to be one-to-one, it must also pass what we call the horizontal line test. So for example, this function is not one-to-one. Hopefully you remember from looking at our graphs of sine and cosine, the graphs look like this, which is clearly not one-to-one. It does not pass the horizontal line test. So what we're going to do in the next set of videos is we're going to look at each of these individual functions in detail. But as a summary for you, the inverse of sine has this restricted domain and this range. Inverse of cosine, each of them are listed here. And then I've also put in the graphs for you of each of these, what we call inverse functions. And what these inverse functions mean, so for example, the inverse sine of x equals y implies that y is the angle whose sine is x.